Hi everybody, welcome to another video in Business Calculus, section 12.1, Antiderivatives and Indefinite Integrals. So we spent most of the class studying about derivative, and in this chapter we study about antiderivatives. First, the definition. A function capital F is an antiderivative of the function if its derivative is equal to the function f. The key here is, of course, antiderivative, but it is one of the antiderivative. Let's look at this example. You'll see the function x to the fourth is an antiderivative of 4x cubed, since derivative of x to the fourth is 4x cubed. And we see that antiderivative is not unique, because we can have another function that will give the same derivative. Alright, so visualize as follows. We have one of the antiderivative x to the fourth. If we differentiate, we'll have the function 4x cubed. And then we may have, actually we should have infinitely number of antiderivative. As long as we add a constant to it, we know derivative of a constant is 0, so that's why it doesn't matter. So we say that this is one of the antiderivative, this is one of the antiderivatives. Right. So in particular we have the theorem. If derivative of two functions are equal on an open interval, then the function differs by the constant. Right. So derivative of these two functions are the same, and it's only differ by a constant 3. Symbolically, if f and g are differentiable functions, derivative of f equal to derivative of g for every x in the interval, then one function is equal to another function plus constant. So that's like what we have here. So derivative go this way, antiderivative go the other way. But since there are many functions that have the same derivative, the antiderivative is not unique. So because it's not unique, we have to introduce a new way to write the antiderivatives. Right, definition. Indefinite integrals, formulas, and properties. We use the simple elongated s, f of x dx, as the indefinite integral. So the name for that is indefinite integral. Later on we will have definite integral. The indefinite integral refer that it's just the elongated s by itself to represent the family of all antiderivative of f of x. And there's a typo, there should not be a derivative sign here. Right. So we write the integral of f of x is equal to any antiderivative plus a constant. So because it only differ by constant, we can choose any antiderivative. So f of x here is any antiderivative and c here is a constant of integration. Constant of integration, constant integration, and that elongated s is the integral sign. And f of x is the integrand. Right. One important thing about this notation is that we will specify the variable that we integrate ds and elongated s, the integral sign. So think about this as the quotation mark. We cannot have one without the other, right? So when you open the quotation mark, you have to close. So the notation here is the integral sign is to open, and then dx is a close. So they have to go together. One of them gone, the other one will be gone as well. Whatever we integrate will be the function in the middle. So the notation has the open and the close part of it. So always go together, the integral and dx. Right, now the rules of integration or integral. X to the n power. So this is like the power rule. Power rule of derivative is take the power down, original power minus 1. This we do in reverse. Instead of multiply, when you take the power down, we multiply, we divide. And not we divide by that, we increase the power by 1. So we reduce the power by 1 in derivative, we increase the power by 1 in the integral for power rule, and divide the same thing as the power as the integral. Now there is the problem with this formula, because when n equal to -1, -1 plus 1 is equal to 0, we cannot divide by 0. So when n equal to -1, we cannot use that formula. In fact, we have different formula when n equal to -1. So this is the special case when n equal to -1. Then x to -1 dx and or 1 over x is ln of absolute value of x plus c. The reason we need absolute values because over here we only require x not equal to 0, because divide by 0 is undefined, so we have to exclude that. Over here ln, we cannot have ln of a negative number, so we throw in the absolute values there, so we turn everything to positive. So that's why the ln will be defined. So we need the absolute values there. And then the exponential rule, e to the x is equal to e to the x plus c. Now, of course, we talk about indefinite integral are families of all antiderivative. So we're going to add the constant c. So we will include all the antiderivative. Without the constant c, we have one of the antiderivative. With the constant c, we have all the antiderivatives. Right. And then some properties of definite integrals. Now these properties is the same thing as for the limit and the same thing for derivative. If we have a constant times the function, once again, the open and close, the quotation mark of integration. If we integrate that, the constant k will come out if k is a constant. And then the sum, I should say, the integral of the sum is the sum of the integrals. A difference of, okay, let's say that again. Integral of a sum is the sum of integrals. Integral of a difference is the difference of the integrals. Pretty much we can split the integral, or we take the constant outside, exactly as we did for derivative. Right. And I think I forgot some rule here. Let's put some more rules. So what happened, let's say if k is a constant, then what is the integral of k dx? So again, integral dx, the part in between them is the function that we integrate. Right. Now I can do this, introduce x to 0 power, because x to the 0 power is 1. So multiply by 1 doesn't do anything. Now we use these properties, we can take the constant outside. can take the constant outside, and we use visualize like this. And now we use the power rule. Increase the power by 1. Increase by 1. And divide by the same thing, 0 plus 1. And then we need the constant of integration. So that gives us k times x to the first power over 1 plus c, and that gives us k x plus c, because divide by 1 is itself. So the power rule not only including those two, including this as well. Just going to say this: integral of a constant is equal to kx plus c. So power rule will have 3 formula, right? Right, let's look at the first example. Okay. Now, this will just have a constant. So this will be have just 5 times x, the variable, plus c. So normally we write the dx, and then you say, why don't we write something else and we use dx? Well, there's a reason for that. In the future section we will see that why we use this notation. But once again, integral sign and dx acting like an open and a close for the integrand in between, which is the one we integrate. So a constant, integral of constant is constant times x plus c if x is the variable. Just like that. Now here we can take out the 3 and we have integral of e to the x dx, and integral of e to the x, it's just like derivative of e to the x, it's just e to the x, and then the power rule. So in that case, integral of e to the x, it's just e to the x, and there's a 3 in front of it. Sorry, there's no more dx. That would be a terrible mistake. Don't ever do that, because when we integrate, we no longer have the integral sign, and when that disappears, the dx disappears. All we have is a constant of integration plus c. Right? Now, just want to say this: in the future, just like derivative, when we learn about, we take derivative of individual terms. Like this, we just integrate for that term, will give us t to the 7. The power increased by 1, and we divide by the same thing. Every constant multiplier will stay the same. We have negative 3. We stay like that. And then plus the constant c. Right, so we have negative 3 t to the 8 over 8 plus c. Right, of course a at the bottom we can write as negative 3 over 8, right, t to the 8 plus c. Right, so we integrate individual terms, and then we just combine them at the end with the constant, any plus or minus in between, we'll do the same thing. Right, and to the next one. So like I said, we focus on the power rule and exponential rule. For x squared, integral will be increase the power by 1. Of course, later on you do not need to write on the color code like what we do in here. Right. For x, this is the same thing as x to the first power. So I have x to the first plus 1 over 1 plus 1. And then 3 is a constant. Integral constant is just that constant times x. Right. And then we have every constant will stay 4 times plus 2 times. Every constant will stay, and the plus or minus in the middle will stay. And then don't forget there's a constant of integration. Right, so that gives us 4x cubed over 3 plus 2 times x squared over 2 minus 3x plus c. So the 3 at the bottom we can write as 4 over 3 x cubed. This is 2 over 2, which is just 1, right? 2 over 2 is 1, so we don't even need to write that. And then plus c. Now, integral exponential function e to the x, integral will be the same. And how do we do that? Well, before we do that, I will want to rewrite this as follow: e to the x, and recommend that we will take the 2 outside like this, times 1 over x. So, which is the same thing. And now we'll integrate exponential term is the same thing, 1 over x. Power rule when x equal to -1 is ln of absolute value of x plus c. Right, so and then you say, wait a minute, why each one may have a constant? Why don't we have only one constant at the end? Well, think about this. If we rewrite this differently, I'm still write just 1 over x like this. We can split into 2 integrals. Like I said, every time we split, the integral side will always have to have a closing dx. So integral open, close dx to have for both of them. Now for this one, we can write integral of this as e to the x plus c. And for this one, we have 2 ln of absolute value of x plus another constant. We can say that this is subtract, by the way, constant 1 or constant 2, because they don't have to be the same and they do not need to be the same. However, if we add the constant here to another constant, a constant plus a constant is another constant. So that's why when we do this, we only need one constant at the end, because we might have more than one constant, but when we combine all of them, we still have a constant. So that's why in all of this integral, we only need one integral at the end. Of course, we might want to write like that, or we can write that as x to the -1. Yeah, x to -1, we 1 over x, we move the x from bottom to the top, become x to -1. We can also write like that. In this case, we definitely need to write like that. So x squared from the bottom move to the top, becomes negative. Now just power rule. increase the power by 1, so 2 over 3 plus 1 divided by the same thing. And then plus 3 x to negative 2 increase the power by 1 divided by the same thing. So 2 over 3 plus 1, 1 is 3 over 3, so one is 3 over 3, and combine the top, we have 5 over 3. Common denominator is 3, just need to combine the top. So x to the 5 over 3 over, of course that would be the same thing, 5 over 3 plus 3 times x to the negative 1, because negative 2 plus 1 is negative 1, negative 2 plus 1, so negative 1 plus c. Now, divide by 5 over 3 at the bottom, multiply reciprocal. So we say 3/5 x to the 5/3. 3 divided by negative 1. And then we have x to negative 1 plus c. So 3 divided by negative 1 is negative 3. So pretty much the integral, we don't have a lot of rules as derivative. Just the power rule, we have 3 of them. Actually, yeah, 3 of them. It's general power rule for the constant, and when n equal to negative 1. So that's the power rule. And the other one is exponential rule. Integral of e to the x is e to the x itself. Now, of course, in order to do the power rule, we have to write everything as a power, just like when we take derivative. If we use the power rule, so we need to rewrite this as a power. If I rewrite it, the notation is still the same. I mean, the notation is still there. The variable doesn't really matter. This case t, right? So open and close. So what formula do we use? Alright, so we have the square root and then the cube root. So remember, in power rule we use, when we mean say b to the m over n like this, it's going to be b to the m divided by n. So power on top, root at the bottom. So if we use that property, by default, this is square root, so that by default there's a 2 there. So we rewrite t power 5 on the top, 2 at the bottom, right? And then 2 times cube root of t. By default we can say t to the first power. So we have t power on top, root at the bottom. So that gives us negative t to the 5/2 plus t to t to 1/3. Actually, I just rewrite this dt. Yeah, this is actually identical. I didn't do anything there. Right. Next, we apply the power rule for each one of them. Original power plus 1 divided by the same thing. Original power plus 1 divided by the same thing. There's a 2 in front of it, and plus and negative and a constant. Right. 5 over 2 plus 1, we can write 2 over 2. So that is 7 over 2. Of course, if we use a calculator, (5 divided by 2 plus 1), we can hit math and change to fraction. So that gives us negative t to the 7/2 over 7/2 plus 2 times 1/3 plus 1, that will be 4/3. Right. Divide by fraction. We have a fraction at the bottom. Multiply reciprocal. And then 4/3 multiply reciprocal. So when we divide by n plus 1 at bottom, if it is just one number, we're going to put that at the bottom, just at the bottom. If we have a fraction, so we just multiply by reciprocal. So negative 2 over 7 t to the 7/2, and then 2 and 4 cancel out. By 2, we have 3 over 2. T to the 4/3 plus c. Right. The next two problems, we have like the product and the quotient. Too bad in integral we don't have product rule or quotient rule. The only thing we can do is to simplify this. By simplify, I mean write that as a polynomial, or write that as a single terms where we can integrate. Right, so we multiply the amount. X squared times 2x, 2x cubed. X squared times minus 1 minus x squared. 3 times 2x, 6x. 3 times minus 1 minus 3. Right. And now we have individual terms. We can integrate them. Alright. Now, x cubed. When we get used to it, we just say increase by 1. So 3 plus 1 is 4, divided by the same thing. X squared integral, the power is 2, increased by 1 is 3, divided by the same power, and then plus 6. By default is to the first power. And then integral of 3, that is a constant, so we just multiply by x. And a constant integral, constant integration plus c. Right, now this is just a number, whole number, so we just put at the bottom. Just put at the bottom. But we cannot just leave like that, need a placeholder, so put 1 there. 6 over 2 x squared minus 3x plus c. So that gives us 1 over 2 x to the 4th minus 1 over 3 x cubed. 6 divided by 2 is 3 x squared minus 3x plus c. Right, so we need individual powers, so we can apply power rule for each individual power. Right, number 9. This one, once again, no quotient rule here, so try to simplify. So there are two ways we can simplify this. One of which I usually see students doing this way than the other. X cubed from the bottom move to the top. And now we multiply them out. Right? we're multiplying them out. Let's just say this. If we have multiply two terms with the same base, simply add the exponents. If we divide, we subtract the exponent. So x cubed times x to negative 3, anyway, switch that, is x to the third right. Multiply, we add the exponent. So x to the 0 power 3 minus 3, 0. And then 2 minus 3 is to the negative 1. Right. Anything to raise to 0 power is 1. So that is just 1. And then I just gonna leave it like that. Now integral of a constant and integral of x to negative 1. Well, x to negative 1 is just like 1 over x, and integral of that is ln of absolute value of x. There's a 2 in front. Integral of constant, just multiply by x. Constant of integration is a constant c. So we can say it's x plus 2 times ln of absolute value of x plus c. Right? Yeah. So if we can write the individual powers, we can simplify. Of course, there's another way to do this. So we can split like that with a common denominator. And now when we divide, we subtract. 3 minus 3 is 0. Then we still have, I don't know why we have a 3 here for no reason, sorry. The common denominator is x cubed. X squared over x cubed, subtract the exponent. 2 minus 3 is minus 1. Of course, we have the same thing and we proceed the same way. Right? So either we write like that or like that. We should have individual terms to integrate. So remember, no power rule, no product rule, no quotient rule. Right. Now we have a little application here. Find the equation of the curve that passes through the point and the slope is given by this, meaning that we have the derivative and we have a point. Right? So if we have the derivative, let's start with this. How to get back to the function? Well, the thing that undo derivative is antiderivative. So when we say like that, if we want to get rid of the derivative, we will integrate. And remember, when we integrate, the notation is like that. Right, so integrate 2x. We just integrate x to the first power. So increase the power by 1. 1 plus 1 is 2 over the same thing. Then plus the constant c. So we have 2 over 2 x squared plus c. Or just x squared plus c. Right, that's good to know, because antiderivative will undo the derivative. Actually, integral will undo derivative. That's a more precise statement. So we have all the antiderivative where we add a constant c to it. Right, one thing we haven't used is the condition. So we say it, y of 2 is equal to 5, meaning that and x equal to 2, y equal to 5. So here we have y equal to x squared plus c. So I'm going to put 5 in for c and 2 in for x. So we have 5 equal to 4 plus c. Subtract 4 on both sides, we have 5 minus 4 is 1 equal to c. And then we can substitute. So at the end we have y equal to x squared plus 1. Right. So this type of problem is called a differential equation. In more particular, it's called the initial value problem, because we have the initial values for one values of x, there's a corresponding values of y. So this condition itself is called the initial condition. And altogether is a differential equation with initial condition. This is a differential equation, the equation with derivative. So differential equation with initial condition. Let me just write out. This is a differential equation. And if it is equation, then there will be a solution. So here what we call this one is a general solution, and this is a particular solution. So this one is called a general solution because there's a constant c. And when we solve for the constant c using the initial condition, what we have is a particular solution. Right, so that's some terminology. Differential equation with initial condition, when we solve for it using integral to undo derivative, we have a general solution. Now use initial condition, we can solve for that constant, and that gives us a particular solution. Let's look at another example. Find the revenue. Okay, the revenue is r of x when the marginal revenue, and we talk about this marginal means derivative. So we have derivative is equal to that, and when no revenue resulted, zero production. Well, that makes sense. If we do not sell anything, we do not have anything. So in this case, we can say that what it means is at 0, the revenue is 0. If we sell nothing, we will not have any revenue. So that makes sense. So the problem is, or we say the problem becomes solve for r of x if, now this is a differential equation, derivative is equal to that. Which initial condition? Right, so that is the problem. Now this is the solution. We solve it. We start with derivative. To undo it, we have to get back to the function by integrate. So get rid of derivative by integrate. Right, this is a constant. Integral of a constant, just multiply by x, and this is x to the first. Integral of x to the first, increase the power by 1. 1 plus 1 is 2 over same thing, plus constant c. right? 400x divided by 2. So 400x divided by 2 is 0.02 x squared plus c. Now we have the initial condition of 0 equal to 0, x equal to 0, then r equal to 0. So we substitute in 0 for r. We say r0 is 0. So regardless 0 on this side equal to 400. Substitute in 0 for x. 0 and 0. So pretty much c is 0. And substitute this into the general solution. We have a particular solution. So that and y, it's not y, it is r sub x equal to 400x minus 0.02 x squared plus c. So once again, integral we undo the derivative, and if we have the initial condition, we can solve for constant c. And with that, we finish section 12.1. As always, thank you for watching, and see you in another video in business calculus.